Hi, good afternoon everyone. Today let us try to learn some few transient response of an RL circuit to various functions. Before going to the transient response of RL circuit to various functions, let us try to learn about what are the different functions that are available to us. Let's try to see step by step function. The first function what we have is unit step. These are called standard test function. The first function is nothing but first signal is nothing but unit step. So all these three are called as a standard test functions. Let's try to see these standard test functions such a way that you will get a clarity how these test functions are applied to the RL network and what kind of output, I mean what kind of transient output they are going to deliver. It's very important for academic point of view. Let's try to see here. So let's try to define what is meant by an unit step. So unit step waveform is defined like this. On the x-axis, you are going to have the time t. On the y-axis, you are going to have the function f of t. So here, the f of t, we are going to call it as a unit step, where f of t we can write down it as a u of t. So now, so this is maintaining an magnitude of 1. So this why since 1 is called unit and this function is resembles like an unit. Okay, so this is like 1 and this function resembles like an a step function. Okay, so that's why this function is 1 is called unit and this function is like an step. So previously it is starting like this and it is continuing like this. That's why this is called an unit step function. So how to define this function? Okay, so this function we can define as a as so you can see here this is at t equal to 0, this is a t value is less than 0, this is t value is greater than 0. Now we need to write the function as an mathematical equation. So I'm writing the output function u of t is having a magnitude of 1 for t value is greater than or equal to 0. When t equal to 0 or t is greater than 0, it is having an unity function or it's having a magnitude of 1. That's why it's how u of t is defined. And if it is u of t is 0 for t values are less than 0. So whenever t is less than 0, what is the magnitude they are maintaining is 0 volts. So at t equal to 0 they maintain 1 volt, t greater than 0 they maintain a magnitude of 1. That's why this is how to define a standard function which is also called standard test function. In this standard test function, first function is called unit step function. That's how we have been defined. You can see here this is in time domain and we are going to apply the Laplace transform for this. So Laplace transform of u of t you can write down it as a u of s. So Laplace transform of an constant is 1 by s. Okay, so remember the Laplace transform of an unit step function is 1. When you perform the Laplace transform, this is 1 by s. So this is the first standard test function. Let's try to define the second test function, which is nothing but an ramp function. So ramp means, let's see here, a ramp function. The name itself ramp means you can see some in shopping malls you have some sort of ramp like this. So through this staircase you can you have some sort of staircases. So through this you can walk. So these sort of which has some sort of slope, they are called as ramp function. Let's try to see how this function exists. Okay, so here also I'm going to take the function like this. I'm going to have the x-axis as a time t and at t equal to 0 the waveform is defined like this. So this waveform is defined for t greater than 0 and there is no waveform for t less than 0 and it maintains a slope of m is equal to unity. Why? Because this is a linear line, therefore slope m is equal to 1. and I'm defining this function as f of t equal to r of t. So where r of t is called function. Sir, how to write down r of t? So r of t, how to write down r of t? It's just very simple. So we'll try to write down. This is in the standard format. Y equal to mx form. Okay, when y equal to mx, what is the y-axis you are going to have? So y-axis is f of t and m value is 1 and x-axis is t. So f of t equal to t. So this is the function defined f of t equal to t or r of t equal to t. So this is a function defined for which value? So this waveform is existing only for t greater than 0. So it is t greater than 0 and remaining value you can see here there is no waveform, it is nothing but 0 for t less than 0. Okay, this is how this waveform is defined. When you come to the Laplace transform of this, so when you perform Laplace transform of this, then you are going to get the waveform as r of s is equal to, so Laplace transform of t. So what is Laplace of t to the power 1 is nothing but t to the power n. This is nothing but n factorial divided by s to the power n plus 1. So when you write down this as, now it is nothing but t to the power 1, you can write down it as 1 factorial divided by s to the power n value is 1, 1 plus 1, that is equal to 1 factorial is 1 divided by s square. The next step in the next function what we define is nothing but an ramp function. The ramp function is defined as r of s is equal to 1 by s square, where r of t equal to t, and this is unit step function u of t equal to 1 and is nothing but s. Let's try to define the next function. So when you come here, the next function is unit impulse function. Okay, so there is nothing but impulse it's nothing but impulse function. Okay, so what is this impulse function? So the third impulse function is nothing but it is defined as you have an waveform f of t, and this is a t wave, I mean x-axis is t, y-axis is f of t, and this f of t we are going to write down for an impulse as delta of t. So this maintains a magnitude of 1. Okay, so here you can see here I'm marking the magnitude as 1, and this waveform maintains a magnitude at t equal to 0. Okay, so this maintain a magnitude of 1. So this is the magnitude of 1. So when you define this waveform, this is t greater than 0, this is t less than 0. So for these two waveform, it maintains a magnitude of 1. Now the magnitude is 1. So how to write down this function? F of t equal to delta of t, and this maintains a magnitude of 1 for t value is equal to 0, and it maintains a value of 0 for t not equal to 0. It means t greater than 0 or t less than 0. You can see here t greater than 0, t less than 0, it maintains 1. So when you apply the Laplace transform for this is you can write down this Laplace transform as delta of s is equal to, okay, so when you perform the Laplace transform of this is nothing but directly a constant is there, that's why writing it as 1. Okay, so this is how to write down the three functions: unit impulse function as delta f of s is equal to 1 and r of s is equal to 1 by s square and u of s is equal to 1 by s. So these are the three standard test functions. So what we have been learned today for these three functions, here these are called the three different test functions: unit step, ramp, and impulse function. For all these three functions, let's try to find the transient response for this. Hope you understood the standard test functions. Thank you.